Alright guys, let's see if we can connect all this up and get it to spin, and we'll talk about everything I'm plugging in and why. So here we go. We're going to kind of start with, well, we have to start somewhere, but there's two types of cables or two types of wires. So the orange stuff here is high voltage, so we'll do that last. It's kind of like for safety, but yeah, the high voltage stuff we'll do last. And then there's low voltage, which is like 12 volts. High voltage, you know, it's going to be like 250 volts, 300, 400, 600 volts. Big time stuff. Low voltage, usually when I say low voltage, it's black wiring, and it deals with 12 volts, your regular car battery. So we're going to start off by connecting the controller. This is our controller, all right? The controller has an A and B plug on it, all right? We only need the B plug, B connector for simple testing. A, I just pretend it stands for ancillary or auxiliary. So that's mostly for temperature sensors of various kinds. We get the oil pump temperature sensor, we get a transmission temperature sensor, we get motor 1 temperature sensor, motor 2 temperature, so on. You get the idea. Now there's other things that go on plug A. I believe we connect the transmission shift solenoids on here, but they're really not used in this current version, this implementation, so we don't even have to do that. So I'm keeping it in the box because I just want to protect it, but I wanted to show you what this thing looks like. It's just really the simple PCB printed circuit board. Well, simple. Very complex, but you know, it's a board with two connectors on it is what I meant. This red thing, if you can see it, the red thing is a Wi-Fi card. We don't need it to spin the motor. I can remove it, okay? Doesn't matter, I'll even leave it off. It's for gauges. It will allow you to see some gauges, basically all this stuff coming from the A connector, which we're not using. If we connected that, we could use a laptop, iPhone, tablet to wirelessly show a virtual gauge. It's really cool, but again, not needed for a simple spin up, which is what we're doing. So the controller needs to talk to the inverter. There needs to be communication there. The controller is going to talk to the inverter using 4 cables. All right. I say cables because technically I think that's what they are. Cables means there's multiple wires in there. A wire is just one wire with some sort of plastic or some sort of insulation material around it. But I'm trying to explain things in simple terms. So this is known as synchronous serial communication. Supposedly that runs over CAN bus. We take one end and we plug it in to the controller. Okay, we plug in one into the controller as these 4 cables from the inverter harness. And the other end, we're going to plug in to the inverter. This is a stock factory harness. This plug here is factory. Nothing's changed there. It's all there. I even kept every wire, although there are some that we won't need. I'll talk about those. So 4 cables connected. Each one has 2 wires in it, in what is called a twisted shielded pair. So 8 total wires. We can call this a 4-lane highway. We can call it 8-lane highway, whatever you want. This is our super highway. This is communication. This is what the communication goes through. But, okay, connected like this, even if we hooked up the batteries, nothing would happen because it needs some sort of input. This thing has no input right now. Okay, so to give it input, we will take this. This has, I believe, it has 6 wires on it. The plug has 6 wires. Yours will be different. but straight away we can see that two just go into one wire, which I'm thinking maybe either ground, and then two yellow ones go into one wire, so that's ground or power go into just one wire. And then there's two signals for channel 1, channel 2. I ran them both and connected them both, but we don't need channel 2. It all works on channel 1. When buying your throttle, I strongly advise, and pretty much with all electronics that I buy that are used, I try to get them with what I call a pigtail. Well, everybody calls it a pigtail. It's a connector with a little bit of wire, and this thing had about a foot of wire with it, and that's why I chose that eBay auction. I think I paid $40 for that. And I just had that much and I extended it. But it's important because you get the wires here. You don't have to find the connector, the plug, you don't have to find the pins, you don't have to fight with it and crimp it. And I can twist wires together. Here I soldered them, and I also put them in shrink wrap, heat shrink wrap. But you can just twist them on with electrical tape for testing, that's fine. But stock OEM plug, stock pedal, just clips beautifully, and the other end goes to that same B plug on the B connector. Okay, everything's going to the B connector. A is not being used. So in addition to the 4 cables, in addition to the throttle pedal, what's important and what needs to be connected to our plug B on the VCU is our safety neutral switch. Safety neutral switch here will have a white wire for power. In my case, your wire colors may differ. And then it has a yellow, a blue, and a green. I know the green is park. We're not going to connect park right now. That one does not go to the VCU. It goes directly to the inverter. So let's connect the neutral switch. I cut the wires on the plug for demonstration purposes just so I could isolate this to show you that this is the neutral safety switch. Okay, so with the neutral safety switch connected to the controller and plugged into the transmission, other than black for ground to the controller and red for positive to the battery, I have a fuse on here for safety, and you would connect this to your car's ignition switch key on. So we will connect this to the battery when the time comes. So what else? Well, the next thing we have to do is, right now our inverter is just sitting in the air here in the middle of the floor. It's not connected to the transmission. We have to connect it to the transmission, and the way we do that is using the second part of the transmission harness. The first one, I'm sorry, I forgot to say, the safety neutral switch is from the transmission wire. Okay, so that's the first component. The second one is the MG2 resolver cable here. All right, so this kind of continues the design of this twisted shielded pair. These cables are difficult to build, and they're really special type of cables. Now, what we're not going to connect is on one end, coming off of the transmission end, we have gray and green wires, 2 of them. These are for the temperature I talked about. So these eventually will be connected to the A plug on the controller, but not now. We don't need them, so they're just looped here. So for this part, we're going to take MG2 resolver cable, and we're going to plug it in. See, that says number 2. So this is the front of the transmission. So we're going to go to the MG2 connector and plug this in. So this is MG1, this is MG2. We'll connect that. that way you can see what we did there. Now, the other end, I hope you can see, plugs directly into the inverter plug. The inverter plug, in addition to the 4 cables that run to the VCU, has 2 resolver connectors. A gray one, which goes to MG1, which we're not going to use for the spin test, and MG2. All right, MG2, we're going to plug in, and it just directly plugs in. And something that is special about MG2 is that this plug has 10 pins as opposed to 8 on MG1, because it has the red and blue power wires. Now this isn't negative and positive. These are both positive, and this will go to the battery. We'll connect that to the battery. Off of the inverter plug, since we're here, we have 2 white and black wires. There's 2 of them, but they both do the same thing. They both are grounds, negative of the inverter. So the way the inverter gets its 12 volt power, just to operate it, okay, not to power the motor, it gets the positive from the MG2 plug and negative directly from the inverter plug here. So this is going to go to the battery negative terminal. We'll just connect it here eventually. And the positive, obviously, I also put a fuse, just 2 amp fuses. I think when I use the amp meter on these. So this will go to the positive. So now let's get started with the high voltage. And this is a simple connection, and this is also just factory. If you buy your Lexus transmission, I strongly recommend you get a matching inverter. I think you can mix and match 2007 through 2011, but why do that if you don't have to? I paid $700 for this transmission. Ask the eBayer if they also had the inverter. And when you get your transmission, make sure it has the high voltage. Make sure it has the high voltage orange cables, because these suckers are like $100 a piece if you don't get them with your transmission. Usually if the transmission doesn't have these orange cables, the sellers will strip other things as well. That's not a good thing, so be cautious. Try to find these big ol' garden hose style cables. They just plug right into where they go from the factory. And I didn't even unscrew them there from the transmission. So this is high voltage. This is dangerous stuff, okay? So we got these plugged in. Okay, so what I brought out here out of the garage are just simply some extensions, a black wire for negative and a red wire for positive. And I just use these as extensions because I don't have enough alligator clips, and this way everything will reach. You don't need these wires. What we need to do is give power to our inverter, which is this. And we also need to power our controller, our VCU, so red to red here. Now here's another thing that needs positive battery power. Safety neutral switch we talked about earlier has a white wire that is actually a positive. It actually needs to get positive on that to the neutral switch. Then we have to connect our negative to the inverter, because the inverter needs negative. And we need to connect our negative of the VCU to the battery. And when you do that, it's really great that there should be some LEDs flashing. I hope you guys can see that. There should be some LEDs on here. One stays on, one flashes. So that's great. That tells you that thing's alive. The inverter will not do anything when you connect the low voltage to it. Absolutely nothing. Once we connect the high voltage to it, it will whine. Okay? All right, so now onto the high voltage. the high voltage, just pretend that the leads from my power supply here are simply orange, you know, maybe orange with a white stripe, orange with a black stripe, similar to these, that these are high voltage. So that's our inverter, and we're going to connect the leads from the power supply to here, pretending this is our high voltage battery. I marked it here which one's positive, and I need to mark the negative. Okay, so with the positive and negative leads connected to the back of the inverter here, we're going to plug this in. Now this is a little bit strange. We're plugging into the wall, as I call it. We're going to get AC power from the wall to this white box power supply, which will convert AC to DC to send it to an inverter to then again, this is crazy, convert it from DC to AC so the motor can spin. I know how that sounds, but trust me. Okay, so something I just did here is I shifted the transmission all the way back is park. Okay, one click is reverse, then neutral, then drive. Okay, so I'm going to put it in reverse. It really doesn't matter. This thing will spin in reverse. It will spin in drive as well. So we'll turn it on. Now, I don't know if you guys can hear that. There is a whine, high-pitched whine coming from the inverter. Okay, we have, that should be 30 volts, 10 amps going to the inverter, and it's going to be going to the motors here. Moment of truth, that should be in gear. It doesn't matter what gear. And if I press this throttle, it should spin. Look at that. If you could see the display, jumps above 30 volts. I mean, how can that be 30 volts or more if that box only puts out 30 volts? Kicking in. Okay, so I have to be careful because I'm sending electrons back to the white box. Okay, so now we're going to shift the transmission. All right, guys, so we're in reverse. I'm going to go back. This is in park, and the transmission should not spin. All right, guys, so it should not spin right now. Wow, I may have done something correctly. Okay, back to reverse, we should spin. And we do. One more click. Now, one more click that way to forward puts us in neutral, I believe. It should not spin. It should not spin right now, and it's not. One more click. One more click, and now we're in drive. We should spin the other direction. And we do, okay? I don't want to floor this, as us old timers say. I don't want to put the pedal to the metal because I don't want too much regen going back from the momentum into my little white box there, my power supply. Now, that's it. We're out of gears. This next place, it won't stay there. So this is a 2-speed transmission, and we touched on shift solenoids in there. This is a fully functioning transmission. It will go forward and backwards, forward and reverse, without the shift solenoid switch hooked up. We do not shift gears electronically. You saw me do it manually, and that's how we'll actually do it in a real implementation, whether it's on the steering column or on the floor. I believe the Lexus had it on the floor. It doesn't matter. We'll shift the gears, park, neutral, drive, reverse manually with our hand. Okay? The shifting that happens electronically, it's to change it from low gear to high gear, and I believe a lot of guys just recommend just leave it in high gear because that is not implemented in this VCU. Now, something else I want to talk about. Let's go ahead and turn everything off here. So we want to let me kill the high voltage. To turn off the inverter, I mean, we're doing it manually here for testing, but it's an alligator clip from the, it could be the ground, it could be the positive. So positive here is red to the one with the switch, which is the red and blue wires that go through MG2 resolver cable disconnected. I also had the white wire from the neutral safety switch connected to the same positive lead just because. And that turned off the inverter, that turned off our safety neutral switch, and then everything we want to turn off is our VCU, which is off, the lights are off. So high voltage is off, inverter is off, safety neutral switch is off, VCU is off. One thing I want to touch on here, just for completeness, I didn't demonstrate this, but we can hook up a USB cable here to our laptop, pull up a little menu, and on that menu we can see, it will show us which gear it thinks it's in. The menu interface, it's programmed already into here, saved on the chip. You use that menu to do two things. You really need to do two things to get this to work programmatically. So we kind of covered the physical aspect, the hardware. Now let's talk about a little about the software. What we need to do is something called torque signals. I don't know why Damien doesn't do this by default when he sells it to us, but the settings are zeroed out for torque. So there's two torque settings. There's forward torque and reverse torque. When the torque setting for forward is set to 0, you can step on the throttle pedal till the cows come home. The transmission is not getting any torque input from the inverter, so it's not spinning. It's set to 0. So what we need to do is programmatically on the little menu, set it to like 200 or 500 just for testing. You can go into the thousands on that once you're driving your car. I think I set it to 200, and I wish he'd set some default values just for us noobs so we don't even have to do it. Maybe he doesn't want to be liable for it, but he recommends 200, and then another place there's recommendations of 500. Set it to 200, set it to 500, anywhere in the hundreds is fine. You don't have to set it to 1,000 or 2,000. But basically it's like a governor in the old days telling you how fast you can spin it or how torquey it can be. We have to do that for drive, and we have to do it for reverse. So that's the first thing we have to do. The second thing that we have to do is we have to calibrate our throttle. This is an electric throttle. It's a 5-volt throttle, but either way, you calibrate it by saying, okay, I'm calibrating the throttle using that little menu. And it says, okay, this is like when you let go of it, 0 throttle. Okay, got it. Okay, now press on it. Okay, this is how much it is pressed on it. And you have to do that because kind of every throttle is different and maybe has more or less throw or travel, maybe that's the right word on here. You know, maybe the E60 goes up a 1/4 inch and maybe a Mercedes one goes up 2 more inches. You know what I'm saying? So you have to tell this VCU what kind of throttle you have and how to program it. So I hope you found this video helpful. This is the non-electrical engineer version. Thank you for watching. Thank you for watching. It's a mosquito.